Hi friends, welcome to our channel. In this video, we are going to explain today's daily challenge problem, minimum recolors to get key consecutive black blocks. This is an easy problem indeed, so this problem can be solved by a sliding window. Actually, if we solve this problem itself, then it's just done. But here, what we want to do is also practice the line sweep method or algorithm, because this problem is very straightforward. This is a good example to explain the line sweep algorithm. So here we are given a string, but the string contains only two letters, either W or B. W means white and B means black. So also we are given an integer key. So we want to check or we want to use minimum switches from W to B so that we can get key consecutive blacks. So that's the problem statement. So also here the problem length or the problem size is constrained by this n bounded above by 100. And therefore, this is the small size problem. Overall, it's rather straightforward. Even you can solve it using brute force. So first, I'm going to write a solution using sliding window, because we just need to examine length key window, right? So here's like 7. Now we want to count how many bees in this window, and then we need to use k minus the number of bees in this key window, so that we know if we want this window to be all black, what's needed recolors, and then we just return the smallest one during the sliding window. So this should be rather straightforward. Let's quickly code this one. So here, the count, black count, it would be a running variable, right? So it would be 0. And answer or result should be, let me use a large one, because we want to find the minimum, right? And then we're going to iterate. So basically, let me introduce this n equals the length of a. I changed the blocks to be this a just for convenience of typing. And then basically for I in range, so this n, right? So then we want to examine length key blocks. So here, if currently you are at index I, then if you have a key block, so the starting, so ending at I, and then you should at I, then you should start at I minus key, I guess +1, right? Because then you can see the end index I minus the start index I minus key +1. Then you add 1. This should be the length, right? If you check that, this is nothing but key, right? This is right. So this will be the starting index. So once you know this, you basically know how to check. So if I minus key is greater than or equal to 0, in other words, this is inbound, then we should pop this one, right? And blocks I minus key, if it were a B, meaning that we are shrinking one B from the current state of count. So we're going to decrement this one by 1. So if blocks I, because this character will come into, let's see, right, is at A. If this is going to be in our window, now if this is a B, so then we're going to increment this count by 1, right? So then the current state of count, it means the number of B's in this A starting from I minus key +1, ending at I, right? So this is the number of B's. Then what we need to change actually is key minus this count, right? So then, because we want to find the smallest one, we just use minimum, the pre-state, and then the current needed. And then we just need to return the answer. That's actually all for this problem. If we just solve it itself, let's check it. Yeah, it passes the 2 cases, and then it should be very fast. Yeah, it passes all the cases. So with that done, I guess we finished solving the problem itself. So now let me explain line sweep algorithm. If you have never used this algorithm, so you can check Wikipedia to check to have a a preliminary understanding about this line sweep algorithm. I will assume that you have a certain level of understanding. So now I'm going to copy this this part. So I'm going to call this one version v1. So now let's do this one. I'm going to leave this in, and then here. First I want to do is, there's B blocks, right? So find all the B blocks. This itself is a good exercise, actually. Exercise, right? Yeah. Right, like this. So what we do actually is rather straightforward. We can do so. We have this in, then we have the starts, right? We have the ends, right? So how can we find this? We just need a for loop, right? So for I in, let's also track the character in enumerate this A. So if I equals 0 or I is greater than 0 and I minus 1 is not B, this guarantees this character, this index will be a start of a B block. So we are going to starts append I. This is the one case. And also we want to find the ends. So if I equals n minus 1 or I is less than n minus 1 but ai plus 1 does not equal to B. So this means this index must be an end. I also do an append. So actually you can print out the start. So let's see. And also you can print out f c ends. Let me first run it. We are going to use example 1 as let's see. Oh, did I? Let's see here. Oh, I need to here, right? Ends, right? So now let's run it. For the first block, you can see there are two B's. So it starts at index 1 and ending at index 2. So here, also here, I guess I forgot one thing. I need to check if character is B, right? Because otherwise we always have the 0. Now let's look at. So the first block is start at index 1 and ending at index 2. So there's a 1, 2. Also you have another 2 starting at index 5 and ending at index 6. So this one start at index 8 and ending at index 8. So we have this piece, these two pieces of information. That's actually very cool. So now what we do? So we can use line sweep like this. So line sweep. So we can regard if a scene is a black, we can assign it a 1. If it's white, we just make it 0. So we can use the collections default dict. So first map everything to be 0. And then what we do is this. For start end in zip, right? Starts and ends. So what we do is ds. So this, once you met this this block, so you are going to assign 1s. The start will be add 1, and the end. So here we need write n plus 1 because here we are going to decrement. For example, here at 1 you have 1, at 2 you also have 1, but at 3 you need to have 1 minus 1, that is 0. So this is the one. So you can also print out this d. right? So 1 is 0. Let's see. 1 is 1, and the 3 is -1. But we need to compute the prefix sum to populate this one. So populate the line swap assignments. So basically for say key in range, so we start from I guess from 1 will be sufficient, from 0, because if -1 it should be automatically 0, and then because we have e plus 1, so the largest index will be n, so we write n plus 1 here. So then dk increment is dk minus 1. So now let me print again the d. You will see it makes a lot of sense. So at 1 it's going to be 1, at 2 it's also going to be 1, but at 3, because it's a black, it's going to be 0, and 4 is also going to be 0, and 5, because it's a 1, so it will be 0. It will be 1. So then we get the dictionary. So now we want to get the cumulative sum. Let's see. Cumulative sum. So this will be, we just copy this part and do it again, right? And then you print out this d again. So you will see this index 2 will have a value 2, right? Right. Index 3, from 0 to index 3, you still have 2 because you have 2 b's, right? So then I get all the information. So now what should we do? So we do essentially the same thing as the sliding window. So we have a result. So at most we need to keep changes, right? Then we want to do then consider block of length k. So if your length is n, so you will have such this number of length k sub strings. So now what we do is for I in range 0 to n minus k plus 1, right? Then the block we consider will be k. The block we are going to consider will be from index I, the starting one, to I plus k minus 1, right? Then we want to count in this range how many ones. So what we can do is the number of ones will be d up to this index, that is I plus k minus 1, then minus d I minus 1, right? And then what we do is result equals minimum, result, and the need, and finally we return the result. So this basically works using this very simple problem using a line sweep algorithm. You can check that. Yeah. So actually for this problem, if we were not going to explain the line sweep algorithm, actually we can follow something like this. What we can do is this. Let me do another solution. So this is to explain line sweep algorithm. You can find some problem actually in LeetCode. They are using line sweep. So I'm going to call this one version v2. So now I want to get a version v3. So what we do actually is this. So we have this one, and then I'm going to initialize a d, right? So collections default and dict, and then what we can do is assign everything to be 0. Then what we do not do this. This is too fast. Let me make it slow. So what we do is that if AI is a b, so what we do? So we're going to say di equals 1. So then if you print out this D, so you will get something like this. So as you have a B in your position, you are going to have a 1, right? So now what we do is this. So what we do is we compute the cumulative sum. So basically for I in, or for K in range, so 0, then ending at let's say n will be enough. So we want to just consider those indices. Then dk increment is dk minus 1. So if k is 0, this will be -1, but -1 will be 0. So now let's print this again, right? So you at 0 you are going to have 0. At 1 you are going to have 1, and 2 you are going to have 2. 3 at 3 you are still going to have 2. This is actually the dictionary we get for this one. And then we have the same thing. Now if you check that, yeah, it will pass. So I guess this is the third version. Both version 2 and version 3 are more complex than version 1 because they are sort of indirect. But let me summarize. So here in the version v1, we actually used sliding window. In this one, so the space is O1, right? And the time is O of n. So this is the most direct one. And for this one, actually, we iterated, several for loops. But this is just for pedagogical purpose. And then when I do this one, I think, because this problem is so easy or so direct, so we can directly get this one using the dictionary, right? So here, this is just a slight refinement of V2, still complex compared to version V1. But I guess in version V2, another thing it's actually of its own interest is how you get the starts and end. Actually, you can practice yourself, and if you look at other people's coding, you feel this is very straightforward. But if you do it by yourself, it might be of a different feeling. So anyway, practice makes things perfect, right? So with that said, I guess that's it for the current video. Thank you for